This is Algebra 2-2, Unit 8, Study Guide Review for the final. We just have a few questions here. Make sure that you've gone back through and studied the film if you didn't do real well on that test or if you don't feel adequate at these. Okay, a student in his statistics course wants to determine how many students in the school have after-school jobs. Which of the following surveys would give the best representation of the school's population? If we go to the mall in the evening and ask how many employees attend your school. Well, the problem with that is you've got all these people at the mall that you're asking about. So you would get a whole slide of data from that. Okay? That really is going to the mall. We want to talk about school's population. Give all the seniors a question. Well, is it only seniors that work? No, I've seen some of you guys that are not seniors yet working. Okay? If you go to the basketball game after school and ask how many of them attending have jobs, well, what's the problem with going to something after school? Most of you guys go to work after school. So after school, you might be at work. Give 20 randomly selected freshmen, 20 randomly selected sophomores, 20 randomly selected juniors, and 20 randomly selected seniors a questionnaire asking them if they have jobs. That might work. Okay. If you have trouble with that problem, in the class notes, I had films that you guys watched of the teacher and the student discussing surveys and biasness. Please go to those films from your class notes and study them. Okay. When entering grades for report cards, a math teacher notices that two students have identical mean scores. Okay, so let's picture this. Write our mu and our mu. That means mean. They're equal. This is student 1. Well, actually, we'll call him student X because that's what we refer to him as. And this is student Y. Okay, the means are equal. The teacher also noticed that student X has a standard deviation of 18.6. So from his mean, his scores are within 18.6 below and above. That's a pretty wide spread. Okay? Student Y has a deviation of 3.4. So his spread is much closer. His scores are all within 6.8 points of his mean. This guy's scores are, 37.2. Okay, so let's read our options here. Student Y has lower grades than student X. This is Y. Would his really be lower if this is the same in each? No. Not at all. Because his only go 3.4 below the mean. His go 18.6. The grades of student Y were more consistent than the grades of student X. Consistent has to do with being closer together. So that is absolutely true. Now we need to make sure why the others are false though, because we might have a misunderstanding there. Student Y had more failing grades than student X. We don't know. They may have both had the same number of failing grades. Maybe their mean was down at 20%. So we can't really determine off that. Or they could have been at 90%, neither one had failing grades. So that's not enough information really. The median of student Y's grades is lower than the median for student X's grades. The median should lie right in the middle of their data. If his data is spread clear down here, clear up there, we aren't sure where the median is going to be. We aren't sure where this median is going to be off the mean. So we can't really determine that one either. Okay. Next problem. Number 15. Ooh, a box and whisker plot. Remember we made these? Identify the possible data set and calculate the fences for the potential outliers. Fences, outliers. Remember I told you, you take your IQR, multiply it by 1.5, and subtract that from your lower quartile, or add it to your upper quartile. In order to find out where the edge of your fence is, in other words, anything beyond that would be an outlier. Here is your IQR, interquartile range. You need to take 90 minus 70, that would equal 20. Again, we took 90, the upper quartile, minus the lower quartile, we get 70. Now, minus 70, we get 20. Now we take 1.5 times 20, that would be 30. We subtract it from 70. That would equal 40. So this one would go clear down to 40. Anything below 40 needs to be plotted as an outlier, just a point. 90 plus 20, plus 30, sorry, I forgot my fence, is 120. So anything up here above 120, be a little bit further up in here, that would be our upper fence. So there's our fences. These fences don't match at all. Ooh, 40 and 120, those match. 55, 9, those don't match. And these don't match. Now I'll be honest, the reason that I chose to go with fences first was because I can't really determine where the data is here. I could go ahead with the data and find the mean, the quartiles, and the extremes, but that's a lot of work in each of those problems, and especially where they show an unknown. Okay? You can still get it, but you just aren't certain where that is. Okay, down to the next problem. If the following scores on a student's tests are 78, 88, 92, 95, 83, 89, how will a score of 88 on the next test affect the mean and the standard deviation of the student's grades? Okay, let's look at the mean. 78, 88, 92, 95. Whoops, can we slip an 83 in here? And an 89 in there. I like to put them in order just so we can have a little more sense of what we're doing here. It's 88 plus 83 plus 78. Now make sure we've got them all. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, we've got them all. To find the mean, we would add these up, divide by 6. So we go on 78 plus 83 plus 88 plus 89 plus 92 plus 95 equals 525 divided by 6 equals 87.5. Okay, so 87.5. That means that if we put in a score of 88 and our average is 87.5, it's going to cause average to go up a little bit. Whatever your score is, whichever side of the average it is, it's going to cause a slight increase or decrease that direction. So when it says the mean decreases, we need to mark it out. Now it says that it increases. Does the spread increase? 88. Does that cause a real big spread in this data? No. It's in here real close with the 87.5. It's in here real tight in the middle. So it would cause a decrease in your deviation. Mean increases, deviation decreases. Look at the film online that I have in Unit 8 on standard deviation. You need to understand what it means. A standardized test has a normal distribution. Remember, that's our bell curve. If you remember right, that bell curve actually has the mean right down the middle, if it's a perfect skew. And then this direction, you can look it up in your notes. We said that was 0.03, or not 0.0, 0 point. It's roughly 34.2%, so it's 0.342. Going the same distance this way, it's 0.342. Now remember, that's one deviation. One deviation. Okay? And if you copy down the bell curve, it keeps going out. Here would be 2 deviations. And a -2 deviations. That should be a -1. Okay, let's read some more. So standardized test, the mean is at 68. Standard deviation of 7, 7 points from there to there. So 68 plus 7, 75. 68 minus 7, 61. Find the probability that the score is between 61 and 68. Well, right there's your probability. And you've shown me all the work. You don't need to show any more. I can see what you're doing. Okay. Next problem. Z-scores. Yay, our last one. Z-scores. On the Z-scores, a particular study has shown the life expectancy of elephants is normally distributed with an average lifespan of 52 years. You need to underline that. Show me that you notice that. Standard deviation of 18. Using the standard table below, what is the probability that an elephant will live between 60 and 70 years? Now, if you remember how to get the Z-score, the formula for the Z-score, let me see if I'm on camera, is Z-score equals our mean minus, our measurement minus our mean over our standard deviation. So we're looking at a measurement of 60 minus 52 over 18, or 70 minus 52 over 18. Those are our two goals that we're looking between. We're saying, okay, what's the probability that he's between these two? Well, the Z-score for this one, put it in a calculator, put 60 minus 52, get the answer, and then divide by 18, and you would get 0.444444. 70 minus 52 happens to be 18, so we would have 18 over 18, which is equal to 1. Okay, so we go to our Z-score. For this one, it is 0.44, so we go to 0.4. There we are. 65.54. That's the percentage chance that 65% of the elephants are still alive when they're 60 years old. Now, at 70, our Z-score ends up being 10, which is 0.8413. And so 84% of the elephants are alive up to age 70, but after that, they've lived up to that point. So we can determine how many lived within this range by subtracting 0.8413 minus 0.655, and this is just a percentage, not the actual number of elephants. So when we subtract that, we end up getting 0.1859. So that means 18% chance that the elephant's going to live between those years, to be 60 to 70 years old. Okay, that's the end of Unit 8. Good luck studying. This will be a test on the very first day of finals week.